If you are new to the channel, then subscribe the channel and press the bell icon for further notification. So hello students, welcome you all to this new lecture in continuity. So today we will see some of the results of continuity or some theorems that involves continuity, that is intermediate, mean value, intermediate theorems, and what are the functions which are continuous in their domains. Okay, then let's see this. Now some of the results, if fx and 2x or gx are two functions which is continuous at the point x0, and x0 is a point in the domain of the two, or obviously it should be domain, then only it is defined, functions are defined, otherwise the functions are not defined at that point. But we need to, function should be defined at that point. If it is not defined, suppose here it is not defined, so that's why it became discontinuous. So both are defined also, and it is continuous at x0. If they are continuous, then this is also a continuous, provided that k1 k2 should be finite, you should not multiply with infinite number, then this is also continuous. That means f plus g is also continuous, f into g is also continuous, f by g is also continuous, provided that denominator should not be 0 at that point. Composite function fog, f of g of x is continuous at g of x0, that is at x equal to. So if you say this is continuous at x0 fog, so if you put x0, the gx0 should be continuous and your function f should be continuous at gx0, then only you will say the function is continuous. So you know g is already continuous, we have seen, at x0. So if your f is also continuous at gx0, then you will say it is continuous. That means this line is written, a beautiful line, a composite function, a continuous function of a continuous function, a continuous function of a continuous function is also a continuous function. F and g both continuous, so continuous of continuous is also continuous. Next, if limit extends to x0, g of a is equal to g of x equal to, suppose I have given it a and fx is continuous at x equal to a, this is given, then you can write this one, limit extends to x0 f of g of x, that is fog x, and you know limit extends to g of x is what, that is this one. That means I am going inside, limit extends to 0 g of x, you have seen, you can limit has a free pass, and this is, you know, a, so it should be equal to f of a, or you can write it either this way or this way, both is same. This is more meaningful if you are going putting that inside here limit, because it has a free pass, and this is, you have already defined it a, so that means that should be equal to fa. Now suppose fx is continuous in the interval a to b, that is between a and b, then it is continuous at every point in ab. So if I am saying continuous in ab, that means both a and b included, it is say close bracket, so at every point it is continuous, then that's why it is in the, if I say entire interval, if I say it is continuous from here to here, that means at every point it is in continuity, there is no break from here to here. But you cannot say, you can say from here to here it is continuous, but for the end you cannot say it is continuous here to here. So if I define a range, that is within it is continuous, that means at every point in between that it is continuous, then the graph will not have any break between a to b, it is a continuous graph. Fx may not be defined for, you can see, if it is defined at x equal to a to x equal to b, so it may not defined at x equal to less than a, or it may not defined at x greater than, suppose after that there may be a break, you can see after that just it is defined up to this, after that there is a break, because at this point it is break. So it is not defined at x less than a, because it starts from x equal to a, or it is not defined, and or both can be, it is not defined for x equal to b, greater than b, because you are not seeing at less than a and greater than b, you are seeing from a to b only. So it may be defined, may not be defined, these two sides. So continuity at the end point in this case, so obviously you can say at this point what is the continuity at that, these are left continuity and right continuity, you are looking only at this continuity. So continuity at end points in this case from the left, that is it is continuous from the right or continuous from the left. Which one is left? This one is right continuity, because you are looking from just after a, so it is at a it is right continuity, and at b you are looking just after b, before b, so it is left continuity. This side it should be right continuity, this side it should be left continuity, because you are starting from a, you are looking after a, so it should be right continuity at a, and you are looking up to b, that means it should be left continuity, before b it should be continuous. So this side and this side should be left and right, if I am saying in the interval it is continuous. Now one very great theorem is there. Suppose fx is continuous from a to b and fa is not equal to fb. At a this is the height, fa, fb it is, so these two heights are not equal. Now if you choose any point between these two heights k, you will find a corresponding point in this domain which is also in between a and b. You can see you have a road between a to b, you can draw anywhere, but you have to go through this height, you cannot skip this height. Suppose you go in this way, I'll go so this way, but at some point you have to reach this height, otherwise you cannot reach here. So that is the idea. This point will be lying between A to B in that domain. So that is the idea. The height in between these two, it will attain at some point which is in between A, B in the domain. So let K be a number between A and B. So there exists a number C between these two where it is attaining that height. You cannot skip that height and come here. You have to pass through this height, and this passing point will lie between these 2 points. You cannot pass this one after B, and then you cannot go this way and then you can come. No, because FB, you said FB, this one, your height is here, because here it will not be a function, because you are getting 2 way out. From B you are getting 2 output. It is at B you are giving B, you are getting 2 output. So it is not function, the original definition of function. So you cannot go this way and come around here. So this is not possible, and you check in any other way to reach here. You have to attain this height. Without reaching this height, you cannot come here, and it has to be a function because you are defining function. So that is known as intermediate intermediate value theorem. So there should be some value for which you will get a height which is also between these two. Between AB, you will get a point at which you get a height between FA and FB. Height is also between these two. The point it is attaining, that is also between these two. Now if Fx is continuous between A and B, and Fa and Fb are opposite signs, suppose this is positive, this is negative. So how will define opposite sign? You take product of these two, that is negative. So if this is positive, this is negative, then this is positive, then this, either one should be of opposite sign. Then you can see you reach a point where the height is 0. So there should be a point between A to B where you will get this height 0 using this theorem. Because this height in between these two you will attain, you take any height, okay. So at some point C you should attain that height. So at some point C you should attain this height 0, because height 0 is also a height between the F and FB. So there exists a point between A to B such that at that point your height is 0, or Fc should be equal to 0, or Fx0 should be equal to 0. This is actually x0 which is lying between A and B. So that is also a very good application of intermediate value theorem. Any polynomial Px is continuous at all finite points of x. You remember this one. Polynomial is always continuous. Rational function is continuous where it is defined, that is in its domain. If it is defined in its domain, then in its domain it will be always continuous. Root function, trigonometric, inverse trigonometry, exponential, logarithm, whatever function you have learned. So in their respective domain, these functions, not your box function also you have learned, greatest integer, but that is not continuous in that domain. 2 is in its domain. If you see box function, it is not that 2 is not in domain. The entire x is here, it is domain, but it is not continuous. All other functions, that is normal functions, root, trigonometry, inverse trigonometry, logarithm, exponential, these are continuous in that domain because that is a smooth curve. But this type of function, other functions, greatest integer function, mod function, fraction part, all these other, that you have to check. But these are all conventional functions, these are all continuous in their domain. If you like the video, then press the like button and please give your valuable comments in the comment section.